The whole world is buzzing about AI agents, yet even tech giants like Apple and Amazon struggle to implement them effectively. Apple recently had to retract its Apple Intelligence feature due to hallucinated news summaries, and Amazon's Alexa AI features remain unreliable for similar reasons. Meanwhile, the internet is flooded with tutorials, tools, and frameworks on building AI agents, but the reality is much harder than the polished demos suggest. In this video, I'll share practical strategies for developers to create reliable AI systems. Drawing from 2 years of experience in AI development and insights from leading companies, I'll clarify common misconceptions and provide actionable techniques. Before we build AI agents, we need a clear definition. Search online, and you'll find varying explanations. Most tutorials describe a basic software system that makes an API call to a large language model, LLM. However, true AI agents dynamically direct their processes and tool usage, rather than following predefined steps. A crucial distinction, as outlined by Anthropic, is between workflows and agents. Workflows: predefined sequences where LLMs execute tasks via structured code paths. Agents: systems where LLMs autonomously determine how to accomplish tasks. Recognizing when to use each pattern is essential for effective AI development. As developers, we should always seek the simplest solution. For most applications, optimizing a single LLM call with retrieval-augmented generation, RAG, and in-context examples is sufficient. Instead of implementing agentic systems, a well-structured workflow can often deliver more predictable and reliable results. A prime example is Devin, the AI software engineer. While it claims to function as a junior developer, real-world tests show that it only successfully completes a fraction of tasks. The unpredictability of agentic systems is why most AI applications today rely on structured workflows rather than free-form agents. Whether using Python, TypeScript, or no-code platforms like Make.com or N8N, AI development boils down to implementing effective patterns. Here are 5 fundamental patterns for building AI-powered applications. Augmented LLMs. Enhancing LLMs through retrieval, tools, and memory. Retrieval involves fetching external data to supplement LLM responses. Tools allow LLMs to interact with APIs and databases. Memory stores past interactions to improve context understanding. Prompt chaining. Sequentially linking multiple LLM calls to refine outputs. Instead of asking an AI to write an entire blog post, prompt chaining breaks it down into research, outline, draft, and refinement steps. Routing. Directing LLM responses based on input categorization. Example: a customer service AI first classifies an inquiry before selecting the appropriate response workflow. Parallelization. Running multiple LLM calls simultaneously to improve efficiency. Used for evaluating AI-generated responses across different criteria in real time. Orchestrator worker model. A semi-agentic approach where LLMs assess input and determine the next steps. Example: an AI handling customer inquiries fetches order details, checks CRM data, and retrieves policy documents before formulating a response. A genuine AI agent operates in a feedback loop, continually refining its actions based on environmental input. However, this pattern presents major challenges. No predefined endpoint. An agent keeps iterating until it meets a goal. Increased unpredictability, making real-world deployment difficult. Scalability issues, as seen in attempts to create AI coding assistants. For most applications, structured workflows are preferable over free-form agentic behavior. Even when an AI system works in testing, scaling it for real users introduces unforeseen complexities. Here's how to mitigate these risks. Be cautious with agent frameworks. Many frameworks offer quick start templates, but they abstract too much logic, making debugging difficult. Learning to build core components from scratch will make you a better AI engineer. Prioritize deterministic workflows. Start with controlled workflows that solve a specific problem with high reliability. Example: if building an AI-powered customer support system, begin with simple order tracking inquiries before tackling more complex queries. Expect hallucinations at scale. AI-generated responses can become erratic when dealing with larger datasets. Implement rigorous testing and validation before deployment. Set up evaluation systems from day one. Establish automated checks to measure AI performance objectively. Example: compare outputs against known correct answers to assess accuracy. Implement guardrails. Before presenting AI-generated outputs to users, run additional validation steps. Example: a second AI model can flag potentially misleading or unsafe responses before they reach end users. The hype around AI agents often oversells their reliability. While they offer exciting possibilities, most real-world applications benefit more from structured workflows. By starting small, prioritizing control, and scaling gradually, developers can create AI systems that are both effective and dependable. If you want to dive deeper into AI engineering best practices, check out the links in the description. Also, subscribe for more insights into AI development.